This is the tutorial for Chapter 4, Section 7, titled Writing Equations in Point-Slope Form, Day number 2. So let's take a look at our first problem here. So here we're given just 2 points. And so what we end up having to do is find the slope of the line to start with. So the slope of the line is set up this way. Remember, slope is the change of y over change of x. Well, change means subtract. So I'm going to subtract the two y values over the difference of the two x values. So what I'm going to do is I'm going to start with this 3 here. This is a y value. I'm going to subtract the 5. So I'm going to do 3 minus 5. It doesn't matter which way you go. I could have done 5 minus 3. As long as I'm consistent, it's going to give me the right answer at the end. So I just did this. I did y minus y1. Now I'm going to take the x values. Since I start with the 3, I've got to start with that x values, or that same ordered pair's x value. That's the negative 3. So I'm going to start negative 3, take away negative 9. So I go ahead and do some work there. I got negative 2. And then here I add the opposite, and I get positive 6. So I reduce that fraction, negative 1/3 is what I end up seeing there. And so from that point, I'll take one of the points. It doesn't matter which one, just take one point. Take one point. Either will work. Either point will work. So it doesn't matter which point you pick, just pick one of them, and then use point slope. So use point slope looks like this. It's that y minus y1 equals m times by x minus x1. So I just take one of the points. I'm going to pick this one right here. And I'm going to plug it in for y1 and x1. So y minus 5 equals the slope of negative 1/3 times by x minus negative 9. So I go ahead and add the opposites and distribute. And so I'm left with y minus 5 equals negative 1/3 x, and then minus 3. A third of 9 is negative 3, or minus 3. And then I just have to add the 5 to all sides, and that gives me my answer. Y equals negative 1/3 x plus 2. So that's the slope-intercept form. And so when they want that slope-intercept form, you use the slope formula. If you're given 2 points, use point slope and simplify. So let's practice that again. So I use the slope formula, and I take the y minus y1 right there. So it's going to be negative 1, take away 2. Now down below I do x minus x1. So I'll do negative 2 minus 1. So I add the opposites, and I end up with negative 3. Add the opposite here, I get another negative 3 minutes. So that makes positive 1. So I get 1 no matter which way I end up doing it. You should get 1 as the slope. So just take a point, doesn't matter which one, and use point slope. So y minus 2, I'm going to pick this point right here. Y minus 2 equals the slope of 1 times by x minus 1. And I distribute. So I'm still left with that y minus 2 equals x minus 1. And so I just distributed the 1 over both terms, and that didn't change any numbers or signs. So I add 2 to all sides, and that's how I'm getting y equals x plus 1. So let's take a look at another type of example. And here we have cars. After it is purchased, the value of a new car decreases by $4,000 each year. So whenever we see those units, they're talking about dollars each year. That's a rate of change. Rate of change. And we can see that because it's going down by a certain amount every year. So decreasing means it's going, we're taking away. And so this represents the slope. And so this slope, m, equals negative 4,000. It's negative again because of that word decreases. So it says after 3 years, it's worth $18,000. So this is an ordered pair. This is a value that they're giving us. And so that ordered pair is going by years and then dollars, or value. And so we've got our x values in years, y values in dollars. The years affect the value. And so they want to use v for dollars and x for years. So instead of y minus y1, it's going to be v. So v minus the 18,000 equals, and that was the y value here. So again, the ordered pair was 3, 18,000. So V minus 18,000 equals the slope, the rate of change. It's decreasing by $4,000 every year. So x minus 3, because we're going for 3 years. So we distribute, and I've got V minus 18,000 equals negative 4,000x plus 12,000. So I just go ahead and add the 18,000 to all sides, and that gives me the answer in slope-intercept form. So instead of y, we're using v for value equals the decreasing of $4,000 every year. X is the input, the number of years, plus 30,000. I got that by adding the 12,000, 18,000. So what's this mean? Well, the y-intercept represents the beginning value. This is our beginning value, the initial value. So that's another word I could use in place of beginning. It's the initial value, and it's again that y-intercept, and that's what that represents. And so the original value is $30,000. So again, if I was to graph this, this is what the line would look like. It's a decreasing line, so it should be going downhill from left to right. So this is years, this is value, and it started up here at 30,000. 30,000, and it's steadily decreasing until we supposedly get to zero, value of 0 after a certain number of years. And so again, this line is decreasing at a constant rate, and that constant rate right here is going down $4,000 every 1 year. And so that's what that represents, $4,000 decreases each year. So let's take a look at the next problem. Here it talks about, according to Dolbear's law, you can predict the temperature T in degrees Fahrenheit. So instead of Y or V, we're using T by counting the number of X chirps made by the snowy tree cricket in 1 minute. For a rise in temperature of 0.25 degrees Fahrenheit, the cricket makes additional chirps each minute. So that represents the slope of the line. So the slope, or the rate of change, how much it's changing by, is, and that is represents the number of degrees Fahrenheit over the number of chirps in 1 minute. So degrees Fahrenheit, chirps 1 minute, and so it's actually 0.25 degrees Fahrenheit per number of chirps each minute. And so we're going to use that and an ordered pair. So here they're giving us an ordered pair. It chirps 40 times in 1 minute, and the temperature is 50 degrees. So the ordered pair goes this way. X represents the number of chirps. So this is chirps. And Y represents the degrees Fahrenheit. And I get that by looking at what they tell me right here. T, in this case Y, instead of Y it's T. T is degrees Fahrenheit. X is number of chirps. So we're ready to set up our equation. So we're going to do T equals, or T minus in this case, because our point that they give us is 40 chirps each minute for degrees Fahrenheit of 50 degrees. So T minus 50 equals 0.25 times by X minus 40. So I distribute, and I have T minus 50 equals 0.25x, and then minus, and then a fourth of 40 is 10. So I just have to add the 50 to all sides, and I'll get the answer. So it looks like T is going to equal 0.25x plus 40. And so this is the equation for the temperature for the snowy tree cricket in degrees Fahrenheit. It starts at 40 degrees. That means that we would have 0 chirps, or 0 degrees, or 0 number of chirps at 40 degrees. So 40 degrees it doesn't chirp at all, but then after that it begins chirping. For each chirp it increases by 0.25 degrees Fahrenheit. And so we'll say here it says that you count 100 chirps in 1 minute. So 100 chirps, we can predict out what the temperature will be. So we have 100 chirps. That means that it's increasing. The temperature must be increasing if we're getting more chirps. 100 chirps times 0.25 gives us a fourth of 100 is 25, plus 40, and that gives us 65 degrees. So 65 degrees Fahrenheit is the temperature if those crickets are chirping, or if that one cricket's chirping 100 chirps each minute. And then it says the temperature is 96 degrees Fahrenheit. So let's find out how many chirps you would expect the cricket to make. So 96 is what the temperature is, and that equals 0.25x and then plus 40. So we'd have to subtract the 40 from all sides. That's going to give us 56 equals 0.25x. So we divide by 0.25, and we'll have to move the decimal point over 2 spaces, add 2 zeros, and we'll see that the answer ends up being 224 chirps. It's quite a few chirps at 96 degrees Fahrenheit. So that is that problem. Let's take a look at one more problem here. And here it says you water your plants in your classroom at a constant rate. So that means we have a slope. And so this represents the slope. And so a constant rate of ounces per second. And so after 5 seconds, you have 58 ounces of water. So I know ounces goes on top because ounces is going to be affected. The amount of water is going to be affected by how long we're pouring it for. And so this is 1 point. So 5, we have seconds, comma ounces. That's our ordered pairs. And so our first one's 5, comma 58. But then it says 15 seconds later, after those 5 seconds. So now we're at 20 seconds. We only have 28 ounces. So again, 15 seconds later, after those 5 seconds, so 5 and 15 make the 20, and that's how I got those numbers. So we're going to find the slope of the line. I'm going to do 58 minus 28, and then divide that by 5 over 20. So the slope is decreasing, and that makes sense, because after we have 30 ounces is decreased after 15 seconds. It makes sense because we're pouring water out. As we pour water out, we're going to have less of that y value and more of the x value, because time's going to increase as ounces decrease. So that's my slope. Now let's take a point. I'll just pick this point right here and substitute it into the equation. Y minus 58 equals negative 2 times by x minus 5. And so we go ahead and distribute. Y minus 58 equals negative 2x plus 10. So I'll go ahead and add the 58 to all sides to get y by itself, and I've got y equals negative 2x plus 68. So what's this mean? Well, it means that the water is decreasing by 2 ounces each second. So water is decreasing by 2 ounces each second. And then it also asks how much did we start with. Well, that's what the 68 is. This is the initial amount. Initial amount of water. And that's that 68 ounces. And when will the water can be empty? Well, that's when y is 0. So if y is 0, then we'll solve for how much time it takes for that to happen. So y is 0 means there's no water in the can. So I'll add the 2x to all sides, and I'm left with 2x equals 68. And so I go ahead and divide by 2, and you can see how x is 34. So it takes 34 seconds to empty the can. And so that's why, again, I put 0 in place of y. I wanted to empty the can, and that's how long it takes. So those are the types of problems that you're going to end up seeing on tonight's homework. Good luck.